for the kind words, Neil. I'm going to drag myself down a little bit after being propped up. 3 more things to know about me. I made this presentation last night. I'm working on 2 hours of sleep, and all I had today was coffee. So let's go. Let's go. So while I was making this presentation last night, I was watching my favorite show, Severance. How many of you here watched that show? Okay, so most of you are going to be very confused by this presentation, so that's a great start. Anyway, the show asks a lot of philosophical questions, and I'll kind of tell you what it's a little bit about without spoiling it. And really, it's a philosophical question about who are you? If you had to define yourself to some sort of AI system in maybe a few paragraphs, could you do that? So Severance starts out with somebody waking up on a table in the middle of an office building. They don't know why they're there. They have no memories. They have basic human knowledge. They have some long-term memory. They probably know things about what states there are, how to ride a bike. But other than that, they're a blank slate. So the company doing this is kind of a combination of a pharmaceutical company and a cult. Which kind of makes sense. I did some work for Eli Lilly, and that makes a lot of sense. So it's a company called Lumen. They have some questionable activities there. So the beginning centers around this lady here named Helly, played by Britt Lauer, great actress. So she's the one who wakes up on that table, and she just hears a voice, and the first thing she hears is, "Who are you?" She didn't know. "Can you name a state?" She said, "Delaware." Okay, great. So she has some sort of long-term memory, otherwise no identity. After she tries to escape a couple times, they plop her down in front of her desk, which is this weird computer, and I'm not going to explain what they're doing here, but it's just around finding these numbers that make them feel scared or happy. It sounds very strange, but you should still watch the show. So what Lumen is doing here is they take a person with basic knowledge and no identity. And what they do is they define some sort of identity for them, and then provide them a task, some sort of training or knowledge, and a goal. I'm going to try to work the room here, but the speakers might blow up, so. Okay.
This side's okay. I think that's
this side's okay. All right. Well, sorry, left side of the room. That's just like an AI agent here. So this is going to be AI Agents 101. We're not going to get too technical here. Maybe someday we can have an AI Agents 201?
202.
202?
Okay, yeah,
Something
yeah.
like that. I don't know. Ohio State professor, you can number the class for us. Oh yeah, you mentioned about putting a chip in your head. So cool. This is for you. So just like a severed employee, which is what they're called, they have some basic brain, and that's exactly what an AI model is. So this could be something like a large language model. Most of you are probably familiar with OpenAI stuff, like the GPT family. It could be a small language model, something that runs on board on some device that you have. Maybe you have a drone or something like that runs autonomously. Or it could even be something dumb, like maybe not even generative AI, something like a thermometer inside your house. And then we give that AI agent an identity via a prompt. So if you've done any sort of work with AI, or even if you've used ChatGPT, you've probably given an AI system some sort of prompt. And you do the same exact things with agents. That's really all these are. They're prompts that you give identities and tasks to. So that's a component here. So we're going to do some technical stuff and look at this under the hood. I'm not going to be testing you as programmers here, but software engineers, you might benefit from some of this. So the parts of this are something called a system message. That's when you tell what the agent is. Then you give it context. So context is its memories. So these large language models, if you're using one of those, have some sort of memory, but they don't have access to any of your specific data. So we'll see an example later where maybe you run some sort of ice cream store, and of course, ChatGPT probably will not know your ice cream flavors. If it does, that's kind of scary, but probably it doesn't. And then finally, you give it instruction. You tell the agent what to do. So, okay, let's go ahead and make some here. So, we'll load up the old demo here. So what I'm going to show you here is sort of like an under-the-hood look at what one of these prompts look like. And we're going to make a very basic agent that doesn't actually communicate with other agents, but we'll get to that later. So, okay, so we'll start with an easy one here. So I've created a prompt here, and here's the system message, and let me know if you want me to zoom on this a little bit more. I can probably blow this up.
Yes.
There we go. I can do it today. That good? All right. So we're telling it you're an agent who's an expert in video games. Well, I mean, so am I. But. Okay, so output a list of video games that you think the user would enjoy based on their preferences. And output the list in markdown format, and that's just it's like a fancy format that looks nice to humans. So that's when we tell what the agent is. So we're relying on the context, the memories being on the knowledge that the large language model has. And in this case, we're using GPT-4o. So the instruction we're giving to it is suggest 10 video games for a system, which is something the user inputs, of genre, which is the genre. So up here, I like old video games, so I'm saying, for the Nintendo Entertainment System, give me some platformers. And we can go ahead and run this, and hopefully it doesn't block me with a firewall because this is a new IP address. Okay, good. So there we go. So it actually suggested 10 oh, DuckTales, that's a good one. I'm going to go home and play that. Yeah, great ones, Mega Man 2. Okay, so I know what I'm doing this weekend now. Sorry, family. So there we go. So just that simple prompt, we gave an identity, and it executed that for us. So what about a situation where we want to give it something? How about that ice cream store? Okay, I'm going to try to put this down. There we go. So system, you're an AI agent who recommends ice cream based on the flavor preference of the user. So this might be something that you could deploy to a website, or maybe you have some sort of online ordering system if you don't want to actually have employees that work at your ice cream store. It's kind of the world we live in now. So output the recommended ice cream flavors to a list. So we've got some ice cream flavors I made here: very vanilla, cosmic chocolate, so-so strawberry. I'm getting hungry. All right, so the instruction we're giving it, the user's favorite ingredients are, and that's the ingredients we provide, recommend one or more ice cream flavors. If none are found, say perhaps you should go to Jenny's for something more exotic. Okay. So we have chocolate here as the base input there, so we'll do that, and then I'll scroll this up here, and then there we go. So the large language model actually understands which flavors have chocolate in it based on the data that we give it. But if I say something like my favorite ingredient is like a lamp or something, then it'll say, okay, perhaps you should go to Jenny's for something more exotic. Maybe they have a lamp-flavored ice cream. I wouldn't be surprised, but so there we go. Then we have another one here. Oh, we have a married couple, so this will be a good one. So this is something where it makes a love sonnet. Okay, so married couple. Who's the husband? What's your name?
Fawn.
Fawn? How do you spell that?
F-A-A-N.
F-A-A-N. And what is your wife's name?
Cindy.
Cindy. Is that how you spell it?
No.
Okay, how do you spell it? I'm a programmer, not a spellsman.
C-I-N-D-Y.
All right, so this one is an AI agent that has to tell me what is Shakespeare. So you can even tell it to impersonate other well-known things. So you're helping Fawn create a love sonnet. Be sure to make some rhymes based on the name of the beloved person, Cindy. So write a love sonnet about Cindy. So there we go. So let's see what it comes up with. I'm not going to read the whole thing, but yeah, it did a pretty good job there. So there we go. When first mine eyes behold thou fair Cindy, the beauty shone like stars in night's embrace. With every glance my heart doth grow. I don't know what that word is. I'm entranced by thee. I wonder. So there we go. So those are some very simple examples of how to make agents that only talk to each other. So if you've used any sort of chat program, usually that chat is some kind of agent, and it has its own prompt like that. All right, so interacting with an AI agent like that is, that's cool, but, what's the difference between that and just like an assist or a co-pilot? So where agents excel is, for one, they can run autonomously. You don't have to have a human kick it off to run. They can make their own decisions. You can also have them collaborate with each other. So these situations that we all fear where robots rule the world, you can have that happen if you want. Hopefully you'll have some rules around what they can do and what they can't do. And the way you do that is you can have a human in the middle. And we'll get to some examples of these situations in a minute here. So there are different types of autonomous agents. And some of these don't run on these brand new models. Some of these are things you might already have in your household right now. So they make decisions based on current conditions. So they have no knowledge, no memory. All they really do is, this thing happened, make this thing happen. So a good example here is if you have a thermostat in your house, even if it's from the 70s, that's what it's doing. Technically, it is an AI because it takes some sort of condition and makes some sort of action happen. And a human doesn't do it. Some other examples here are Roomba. At least the old ones, they just kind of go around and they say, okay, dirt here, I eat dirt. Or an automatic door. You go walk into a grocery store, you step on a mat, the door says, oh, mat stepped on, open door. So those are the very first types of agents, and we'll get more complex ones as we go in here. So now we have model-based reflex agents. So this actually does make some sort of internal state of the world around it. Probably the best example right now is self-driving cars. It scans its environment. It sees, okay, this is where the lanes are going, these are where the cars around me, there's people here, these are the decisions I'm going to make. Also autonomous drones. We actually have a customer who does this. They have drones that drive themselves. And they, based on the camera sensor, they know, all right, I need to go here. They have a GPS system as well. And okay, I see down here, this is the type of thing I want to take a picture of. These are the things that interest me. And also, something that probably all of you have in your pocket, Siri or Google Assistant. The environment is what is on your phone, where you are, what you're doing, and it makes some sort of decisions. If you open up your phone right now on your lock screen, it might say something like, hey, you're at Innovate New Albany or Brickhouse Blue, leave a rating here, and please rate 5 stars.
Josh?
Yes?
Quick question. So those autonomous drones literally can recognize things that they're basically being asked to recognize?
Yeah, so the way these work is that the newer ones have onboard chips with something called small language models on them. So they can actually think for themselves and not have to be connected to the internet to do anything. So they have vision recognition, so they can look, let's say if it's a drone that surveys for utilities like AT&T or something like that, and they want to do something like damage prevention, they can go and say, okay, I'm looking for power lines. Oh, there's power lines, snap, 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 snap. Take pictures of it, it lands, becomes internet connected, and uploads whatever it needs to yeah.
Thank you.
Yep.
That's wild.
Yeah, it's pretty cool. Did I skip one, or, oh man, okay. Oh, wait, no, that's right, yes, okay. I told you I'm on 2 hours of sleep here, okay. So goal-based agents is, and we'll look at an example of this in a second here. That's when you give an agent some sort of goal. Maybe it'll work with other agents to do this. I'll send this slideshow out. You don't have to take screenshots. Right. So an example of this are your Amazon delivery drones. You give it a goal of, okay, go to this address, drop off this package. This person needs diapers at 3 a.m. Cool. Navigation systems, you give it a goal of, I want to go to point B, I'm at point A. The goal is get to point B. Or even robotic surgery assistants. This is something that, it's been around for a little bit, but these models are getting way more advanced, the cameras are getting better. So they know that I need to do this for this specific type of surgery. I need to pay attention to the inputs of the surgeons around me. And then finally, we have utility-based agents. So by utility, think of, if you're familiar with philosophy, the concept of utilitarianism, where you make the decision that makes the most good. A good example of that is smart energy systems. where in your house you might have different things in your environment, like you say humidity, temperature. Your thermostat might make the decision to go to a certain temperature to make sure the most people are happy. Or, okay, ride our meal sharing apps. So I don't know if you've ever ordered DoorDash or anything like that, or Uber Eats. But what they do is you put your order in, and unless you pay extra, they make some sort of route where maybe you'll get your food last because it's trying to do the best for the most people. So maybe instead of if you ordered first, if you're the furthest away, it'll actually send an order that came in later, and it'll give that person the order because they're closer. It makes the most sense, and it makes the most people, I wouldn't say happy, because you might be mad that you're not getting your order first. But in the grand scheme of things, for humanity, I guess, yeah, that's what it's doing. And also health management systems. And this could be maybe you subscribe to something like your HR company might have something where you get a free gym membership, something like that. And maybe like the upfront cost would cost the company something. But these systems might determine, based on the age of your employees and their activity level, you should offer this because in the long run it'll do the most good. But yeah, Ray, we need to start offering free gym membership because I'm really out of shape.
Join the club.
Okay, so there we go. So Ray and I need gym memberships. Then learning agents, and these are, you probably have the most familiarity with this. If anybody has a computer and you have Gmail, or if you have Outlook, the spam filter is a great example of this, where it learns, and it's supposed to at least get better and better when you define, okay, this email is spam, this email is not. Again, we'll go back to Siri. That's also learning. It does, let's say you have some notifications. It can tell, okay, this user clicks on their text notifications pretty often, but it ignores all the notifications from, let's say, City Barbecue. They send me a ton of notifications. I don't think I've been there in like 2 years. So Siri actually did learn, okay, hide this. He doesn't care about City Barbecue. I apologize to any City Barbecue employees here. Okay, so given that, there isn't really a good standard for agents right now. Nobody can really agree on anything about, other than what it is. So all of the LLM vendors and some companies like Microsoft, they all have different interpretations of how agents should interact and should run. So OpenAI has their own system. Google does, Microsoft does. Microsoft even has competing versions of how agents should work, and right now that is the nightmare of my life, and we're trying to deal with it. So, I was going to say something, and I forgot. I just lost it. Okay, well, I'll think of it later. OpenAI agents. So you might have heard of the new deep research agent. So that is something that lives inside of ChatGPT, and if you ever have dealt with that, there are some agents that OpenAI built. So deep research is a new one where you kick off a question, and then it'll use this agent to call its reasoning models, which is a little bit different than chat. So it could take like 10 minutes to hours for these responses to come back when you give it some sort of complex problem to solve. So it knows that, all right, my job is to field the user question, decide how complex it is, and then assign some sort of thinking level I'm going to need to solve it, and then finally give that user the result back at some point. And Gemini agents, they have their own way. It's not quite as complex, but again, Google has their own way of doing it. And I know this is probably boring most of you to pieces, but the key here is nobody can agree on how to actually run these things. All right, so how do we actually start running one of these things? So there's the manual way. I just mentioned before, you can do it in a chat or some sort of request to it from programmatically, some API, something like that. Or automating. You can have it run on some sort of timer. We're working with JR over here on an automated cybersecurity vulnerability tracking system. Or a sensor. Again, with the smart cars, we know that they have sensors, they have cameras, they know to activate certain things given their environment. Again, the thermometer, that's a good one. And then these very technical things, so software developers, webhooks, queues, or another agent. And then finally, we know how to start it, but how would you finish one? So again, most of these have some sort of end state, we told it, some sort of goal. So most of the time that's what we do that, and they can either do that where you define some sort of end state, some sort of keyword, or you can even have an AI model itself decide if it's done running. And until then, it'll just keep looping and doing its thing, and maybe you should tell it when to stop if it can't finish. So let's go back to our demo here. So here are our severed employees. So in any organization, you could have one person do all the work. That probably wouldn't work out so well. But really, you want all of them to work together to achieve something. So that's why you'd want agents to work together to achieve certain tasks. So let's go to another ye olde demo. We're not going to do any coding here. And I'm going to go to an agent chain that I built in my platform just because I can do it the quickest in my platform. So these co-pilots here are agents. So I have an agent here that makes a marketing outline based on an image that we send it. And then I have another one that'll write a full report on it. And then I have another one that'll make a product image based on what I've sent, some sort of poster to advertise this thing. So I've got a workflow to do this. So what I'm going to do is I'm going to kick it off, and it needs a product image to start. So I need to actually go find this thing. You think I'd be more prepared, but I'm not. All right, so there we go. So it's an air conditioner. So I've got an air conditioner, and I think, oh no. My kids actually played with this yesterday, and they sent pictures of waffles, and they came up with different waffle products. I'm like, I think the waffle market is cornered, kids, but over to you. So I'll say something like, make a plan for this product, including a product name. So it's probably going to take a little, maybe like a minute to run this thing, because again, we have 3 AI agents working. And the last one is going to create some sort of image that I'm expecting to be very horrible because we're using DALL-E, and whenever you see people make fun of bad AI images, that's what it is. But it's the most fun. On a side note here, if you want good images, there's something called Stable Diffusion. It's really expensive, but it works pretty good. I think it's something like $80 for 100 images. Cheaper than maybe than getting stock photography, but...
What's the name of it?
Stable Diffusion.
Stable Diffusion.
Yeah. So you can either get that by itself, or if you are a Microsoft Azure user, that is included in Azure Foundry, which is its little warehouse of AI models. Okay, so it finished. I'm glad the demo gods don't hate me today. All right, so we'll go up here, and then we see the top one here, and I'll zoom in here as much as I can. So I gave us a product named the Cool Breeze 3000. Oh yeah. So the motto is effortless comfort, anytime, anywhere. So it gave us an outline of target market segments, key features to highlight, some marketing channels, call to action for the customer. And the second one here is we have a whole report. Now I didn't do a ton to specify what should be in this report, but again, you just tell an agent exactly what you want.
Plus it's marketing, so it doesn't matter.
Yeah, that's right. Them's fighting words, Ray, but... and here's the image it made. Some guy in the sunshine looking at his air conditioning. He even has a poster. That's how much of a fan he is of it. Man, wouldn't you love your customers to have posters of your product and just stand there and marvel over your product? Apple sure has that. All right, so back to here on my Apple laptop. So there we go. So that's an example of agents working together to achieve something. So when would you use an agent over, let's say just like a general chat? So the first is when you want it to make some sort of decisions by itself. So note in that last example, all I really did was I told it, like, here's an image of an air conditioner. Go make a marketing plan. So it started that, and it talked to other agents or robots, and it just made its decisions by itself. What you didn't see happen is that these agents have a back and forth conversation. This isn't just like a one thing where the one runs and the other runs and then the last thing runs. They talk to each other to determine if they've met their goals. There's just another example I have, which for the brevity I won't do here, where you can have an article writer and you'll have an editor. You tell the editor exactly the style you want it to edit in, the editor will go back to the author, the article writer, and say, no, change this. You need to do this style. And it'll loop back and forth until the editor is finally happy, and then the last step is that it'll publish it to your website or wherever you want to publish it.
That picture there had 2 units in it.
Sorry?
That picture of the air conditioner had the old-fashioned one, and it had the new one, which is not a window air conditioner.
Yeah, I mean, AI is not very smart about making it.
Well, it had 2 people.
Yeah. Yeah, I agree. I'm not vouching for how good it is at doing stuff. I'm just telling you it'll do stuff.
It's not how well the bear dances that matters, right?
Yeah. And again, when you're working with AI, if it's not doing exactly what you want, you can specify. Like, I didn't really give it any instruction back there, so just the level of the way it did things, such as it is, was, kind of cool.
Can I ask one question about the language? I saw something recently where they have their own language.
Yeah.
Where it's quicker than you speaking English, and that's a real thing, right?
Yeah.
It's gibberish. They call it gibberish or something?
Yeah.
That's a real thing, right?
Yeah, they invented their own. I think what you were talking about is some sort of experiment where you had 2 agents and you said collaborate on making some sort of language together to save tokens. So just to back up here for those of you new to AI, the more stuff you send to an AI, the more words, the more expensive it's going to be to run things. So the point of that is like do these things and really like trim down on how much stuff you're doing. So make things cheaper for me. So yeah, they created their own secret language, and that's kind of scary, but that's what's happening. When they dove down into like the guts of that, it was really like not that hard to decrypt. So it's not like a Skynet situation where we have no idea of like what they're doing. But given advanced enough AI models, you could get into a situation where yeah, these things could be doing some things and we have no idea what. Anyways, with that comforting thought, so if there's the last thing here is if you want them to interact and have a goal, that's when you have an agent instead of something like a chat. Okay, so warning here, for anything critical or difficult to reverse, don't let your agents do it. So don't let them delete things in your database. If you're running something like, let's say you're a health insurance company, and you have an AI approve or reject a claim, maybe you shouldn't do that. Well, wait, they do that. Maybe they shouldn't do that. So in that case, that's when you'd want to have something called a human in the loop. Maybe these agents do make some sort of decision about why they think this claim should be approved or denied, but really, you should have a human actually look at that and say, okay, these things are right. All right. I gave this presentation to a couple friends yesterday, and they're like, okay, well, what about these new reasoning models? How do those differ? So I think I mentioned before, a reasoning model is something that takes its time to answer a question. So you might have heard of, Grok does it. The O3 models from OpenAI, that's a reasoning model. DeepSeek is a reasoning model. So you can use those just like you would in any other agent situation. It might take a little bit more time. The interesting thing about DeepSeek is, when Ray and I were playing around with that, we tried using it in an agent situation. It's weird. It's very, it won't answer a lot of things that it deems it shouldn't answer as far as like cultural clashes and things like that. So you just need to make sure that you pick a really good base model for what you want to do. Grok, for that matter, too. Don't say anything bad about the government, because it'll probably report you. All right. So, anyways,
Here or China?
Either. Don't ask anything bad. I can't vouch for the safety of this world anymore. That's a different Tiger Talk. All right, so the key takeaways here, agents are very good at automated processes. That's when you should use them. So the process of making them is the same as anything else. It's just prompt engineering. But the way that they interact with each other, that is what's different. And there is no standard for how they interact. If you're not already watching Severance, you should just start watching it, like right now. It's an excellent show. Actually, let's just go home watch Severance. So here are some resources here. I'll send this out. So those prompts I sent before I put on a public GitHub repository. And then there's a link to the website where I made those agents. So that's it. Any questions?